Hello everyone, welcome to my YouTube channel. It's me Javindra Paudel, structural engineer. Today I am going to evaluate the story stiffness of multi-degree of freedom structure, which is 13-story mid-rise building with dual structural systems consisting of shear wall and the coupling beam. And the arrangement of shear wall and coupling beam uh, is like this. The green color uh, frame indicates the coupling beam connecting these C-shaped shear wall, and rest of the beam and column arrangement are like this. So in this video, the manual calculation of story stiffness for this structure shall be done, and compare the manual calculation with the stiffness value obtained from the analysis in FEM software like SAP, ETABS and other software. But here today the comparison shall be done in ETABS software. So before starting the video, I want to acknowledge some of the reference which I will be using here. For the manual calculation, I will be using the paper or journal called Estimation of Story Stiffness in Multi-Story Building, published by Professor Murthy and his team, and some lecture notes of Dr. Fawad Nazam, who is a renowned professor in the field of structural engineering. And another interesting thing is that the newly developed Nepal Building Code 105 2020 plugin, which is developed by my friend Binas Sapkota, who is also a structural engineer, and he has in-depth knowledge of programming software in addition to structural engineering software. So this is the overall information of equivalent static procedure uh, based on our Nepal Building Code NBC 105 2020. And for this, we will be explaining more about the every things in next videos. For now, let me focus on the stiffness evaluation of this structure. So I want to say that the aim of making these videos are only for the educational learning purpose, and all the sources are properly acknowledged. The presence of stiffness irregularity in the structure leads to undesirable behavior during the structural ground motions, which includes the localization of lateral deformation and initiation of story collapse mechanism. So it is very important to have a estimation of story stiffness or the quantitative check of story stiffness of its story along the height of the building. So as you know that the building itself is treated as a vertical cantilever, and we see from the result also the stiffness of the structure along the height of the structure will go on decreasing, uh, as well as we call it the flexibility of the structure will be increasing while going up and up or along the height of the structure. So here this is the ETAB model, and this is the analyzed model. If we look into the story stiffness shear with the story response plot for any of the load cases, we will get the story stiffness like this. We can see that the story stiffness is decreasing along the height of the structure and maximum at the ground floor or first story, bottom story of the structure. So the story stiffness will be evaluated manually and compare that manual curve stiffness with this value in this video. So let me turn into the reference paper now. Here in this paper, 7 methods are presented to evaluate the story stiffness of the building and the compare the story stiffness with the base structure. So among the 7 methods, the first one is the sub-assemblies method. Second one is the story frame method. Third one is the box frame method, equivalent stiffness method, single story method. The sixth one is the lateral force deformation method, and finally the seventh one is the lateral translational mode shape method. So out of these 7 methods, the first 3 methods use simple closed form equation, while the last 4 methods used uh, the result obtained from linear elastic analysis to estimate the story stiffness of each story in the multi-degree of freedom structure. So these 7 methods have their own strength and limitations. Among the 7 methods, the first 3 methods they are used only for moment resisting frames, uh, moment resisting frames with the first story column fixed at the base and not for braced or MRF with structural wall. While these 4 methods they can be used for any type of structural systems. And finally, the seventh one called fundamental lateral translational mode shape method can be considered the most accurate and reliable method among all the method, and we will be using this method to evaluate the story stiffness of that model which is presented in ETABS. So in fundamental lateral translational mode shape method, the story stiffness is using the seismic mass present at all story levels and the result of model analysis of the building, mainly the fundamental natural time period and its associated mode shape. By idealizing the building as an equivalent shear beam mathematical model, which can be shown here, or we can evaluate or equivalent make the equivalent structure like this. This is the 2D form plane and the lumped story mass with the story stiffness for this structure. It is a equivalent structure called shear beam or vertical cantilever. So the formula is this, and we can elaborate this formula in the paper. Ki and Mi are the lateral translational stiffness and lumped story mass at each story. Here, the for our case, we have the 13-story building, so that the stiffness ranges from K1 to K13. The transpose it is in row form, and after transposing, we will get the stiffness of each story in one column as of story wise or floor wise along the height of the structure. So the story stiffness for the first floor is W square, which is uh, lateral translational circular frequency, and I summation I equals to 1 to n, n for story masses and uh, story mode shape of that story. The product of story mass and mode shape summation means for story 1 we have to do summation from story 1 to story 13, like m1 into phi 1 plus m2 into phi 2 goes to m13 into phi 13 divided by phi 1, the respective mode shape of story 1. Similarly, for 13 story, w square into m13 into phi 13 divided by phi 13 minus phi 12. It will be clearly explained in the Excel sheet. So let me turn into the ETABS model. For detailed ETABS model, I will be explaining in the next video. which will be related to equivalent static analysis. The material has been defined as M30 and M20 for M30 for vertical structure and M20 for slab, and sections like a column is defined as 600 by 600, girder or beam is defined as 400 by 600, and coupling beam is of 300 by 1100. Likewise, shear wall is 350 thickness, and the slab is 150 thickness. The load has been applied, the gravity load, dead load and the UDL load has been applied in this model, and I'll be explain everything in next video. For now, for now, we will be using the lumped story mass of each story for the evaluation of story stiffness. If we go into the other definition here in the table, mass data called mass story by diaphragm. Yes, this mass will be using this mass in the evaluation of story stiffness, and the time period of the structure like displays, show table, structure output, model information, like model period and frequency. Let me check. Okay, this is the model time period and frequency for cyclic frequency for the structure, and we will be using this two value or this value. This can be obtained by if we have the time period, if cyclic frequency W can be obtained with the formula 2 pi upon time t. So let me turn into the manual calculations here. Before going into the evaluation of story stiffness, let me go briefly about the manual calculation for seismic loading according to Nepal Building Code 1052020. This sheet is developed based on the equivalent static analysis presented in the Nepal Building Code 105, which is recently published. And the calculation of time period can be done in model time period can be done in two ways. The first one is the calculation of time period with the empirical method with this formula, and amplification of time period as per the codal provision, and finally we got the time period of 1.024 second. Again, for further clarity or further check of the structure or the model time period, the evaluation of time period can be done by using the relic method. The detailed notation of these values and the detailed calculation I will be I will explain in the next video. For now, let me go to the obtained time period from the relic method, which is 1.096 second, and from the ETABS we got 1.138 second, which is near about the two values are close, very close to each other. So uh, I'll be using this time period for the calculation of story stiffness, and let me go to the stiffness calculation chart. Here this is the time period and the corresponding cyclic frequency W is 5.733 with the formula 2 pi by t. So for the calculation of story stiffness, let me turn from the story 13. For that, we need the story, as I have already stated that we need story masses. Here, these are the story masses from story first to story 13. And this is the generalized mode shape for story first to story 13. This is the mode shape. plot of the value obtained from the ETABS. And the calculation of story stiffness goes like this. For the story 13, this formula applies for story 13, which means W square mean this W square into M13 into phi 13 divided by phi 13 minus phi 12. Okay, W square into M13 into phi 13 divided by phi 13 minus phi 12. S33 means phi 13 minus phi 12. Similarly, for 12 story, uh, the story masses of 12 and 13th story should be taken with the according to this formula, and like this W square will be the same. D 33 means phi 13 into M13 plus phi 12 into M12 divided by phi 12 minus phi 11. Similarly, for the 11th floor, the product of story masses and mode shape of 11, 12, and 13th floor can be done with and divided by phi 11 minus phi 10, and W square value is the same. Similarly, while calculating the story stiffness of the first floor, as we know that the story stiffness goes on increasing towards the base of the bottom of the structure, so that all the story masses and mode shape product value can be added from story first to story first to story 13 and divided by the mode shape of story 1, which is H45. H45 means mode shape of story 1. So by this formula and doing transpose, we got the story stiffness value from story first to story second. And if we turn into the ETAB here, the story stiffness can be plotted on story response plot, story stiffness in x direction. It is the load case is equivalent static analysis according to NVC 1052020. And for the ultimate limit state, the stiffness for ultimate limit state and serviceability limit state will be different. This blue graph shows the stiffness along the global x direction, and if we look into the value here, these are the stiffness value for the floor wise, ranging from story first to story 13. So if we look plot the value, if we paste the value in the graph here, these are the story stiffness value obtained from ETABS, and the value, this column has the value summarized from manual, and the plot of this story stiffness value is here. The red plot shows the manual calculation of story stiffness, and the blue one shows the ETABS calculation. And from this plot, it can be said that the story stiffness from for the manual calculation and ETABS is very close to each other. So the seventh method, this lateral fundamental translational mode shape method can be considered as the accurate method and reliable method for the stiffness evaluation for any type of structure. So here in this paper, um, the story stiffness can be used with the fundamental time period obtained from the model analysis with the associated mode shape. But here in my Excel sheet, I used the time period which is calculated manually. So let me put the value obtained from the ETAB model, and we'll see the difference of the story stiffness. So 1.138 is the time period. I'll put here 1.138, and cyclic frequency also changed. So let me see the stiffness evaluation for manual calculation and ETABS. So while using the time period, model time period obtained from ETABS, the story stiffness of manual calculation is slightly lower than the stiffness calculated by ETABS. As we know that ETABS is a finite element software, and the evaluation of story stiffness is based on the finite element method. So it is obvious, it is uh, reasonable to say that the manual calculation of story stiffness is slightly lower than the stiffness value obtained in the finite element software. So this is the overall estimation of story stiffness and the comparison of story stiffness with manual calculation with the ETABS value, and which is uh, closely related or closed with the uh, value obtained from the finite element software. So this much for today. In the next video, we will explain the statistical analysis equivalent static procedure in ETABS and also in manual calculation, and compare the response of global response of the structure like drift, displacement, overturning moment, shear force, lateral force with the ETABS value. So till then, uh, please subscribe my channel, like, comment, and any valuable suggestion will be highly appreciated. So have a good time, stay safe and stay healthy. Okay, bye bye.